Okay, so you've sent over this great collection of info, really centered around the AI Index report for 2025.
That's right. It's pretty comprehensive.
Yeah, it looks it. So for this deep dive, let's try and, pull out the really crucial stuff, the big insights, maybe some surprising facts, key takeaways about where AI is right now, and I guess where it's heading, all sort of tailored so people can get up to speed quickly without getting totally bogged down.
Exactly. And the sources you pulled cover, well, basically everything. R&D, how well the tech is actually performing, responsible AI, which is huge, the economy, science, medicine.
Policy, education, public opinion, the whole shebang.
The whole lot. But yeah, the goal is to zero in on what really matters for understanding the big picture.
And honestly, some of it sounds wild. We're talking Nobel Prizes linked to AI, which apparently, yes, has happened.
It has, yeah. Pretty significant validation.
And how fast AI is getting better at really tough benchmarks, then stepping back to see how, governments are trying to keep up. Okay, let's jump in. Where should we start? Research and development.
Makes sense. That's the engine room, really. And one thing that stands out immediately is, well, it's still the U.S. and China leading the pack in AI research publications.
Right. That's been the case for a while, hasn't it?
It has. And if you look at 2023 specifically, Google and Tsinghua University were kind of neck and neck at the top in terms of highly cited papers.
Interesting. Google, an industry player, right alongside a top university.
Exactly. And that's a key trend. Industry is playing a much, much bigger role alongside academia now. It's not just labs anymore. That mix is really driving things.
Okay, so that collaboration is key. Now, the report mentions they changed how they track publications. Something about OpenAlex. Why is that relevant?
Yeah, they switched to OpenAlex. Think of it as a more open and maybe broader way to count research papers, but there's a cache, or something to keep in mind anyway. The report itself flags that by focusing just on papers tagged as computer science, they might actually be missing some AI research that's happening in other fields.
Like medicine or finance using AI tools.
Precisely. So the numbers we see for the U.S. and China are strong indicators, but the total amount of AI research globally could be even larger than reported there.
So potentially more AI activity than meets the eye. What about patents? That's usually a good measure of innovation too, right?
Absolutely. And patents show a similar picture. North America and Asia are way out front. It just reinforces that these regions are where most of the new AI tech is being created and well owned.
Okay, so R&D hotspots are US, China, same for patents. Now, the actual AI models, are we just seeing more and more released every year?
Actually, no. The total number of significant new models released has dipped a bit recently.
Really? Why is that, do you think?
Well, it probably comes down to resources. Training these cutting-edge models takes absolutely vast amounts of data and incredible computing power.
So it's getting harder, more expensive to build the really big ones.
Exactly. It suggests maybe a shift towards fewer, but much larger, much more powerful models, rather than just churning out lots of smaller ones. Quality over quantity, perhaps.
That makes sense. And speaking of larger models, the training data sizes, the report mentions some, frankly, staggering growth there.
Oh, yeah. Staggering is the word. The amount of data used for training large language models, LLMs, it's basically exploding, doubling roughly every 8 months or so.
Wow. Give me an example.
Okay, so GPT-3, which was considered huge at the time, trained on around 374 billion tokens. Sounds like a lot, right?
Yeah, definitely.
By summer 2024, Meta's Llama 3.3 trained on 15 trillion tokens.
15 trillion! That's insane. I can't even picture that.
It's astronomical. And it just shows the sheer data hunger of these state-of-the-art models.
And training time must be going up too, then, with all that data.
It is. Some of the really big ones, like Llama 3.1 405B, reportedly took something like 90 days to train.
3 months just to train one model.
Yep. It underlines the huge investment needed and brings up that big question.
Yeah.
Are we going to run out of data?
The data scarcity problem. I've heard about that. Does the report mention solutions? Synthetic data, maybe?
Yeah, it touches on that. Synthetic data, AI-generated data, is definitely one avenue being explored. There were early concerns, that models trained only on synthetic data might lose touch with reality, sort of.
Right, like an echo chamber.
Kind of, yeah. Model collapse, they call it. But newer findings suggest that using synthetic data layered on top of real data helps avoid that collapse.
Okay.
Though, importantly, it doesn't automatically mean the model performs better. So it's a useful tool, a supplement, but maybe not a magic fix on its own.
Got it. Synthetic data helps, but doesn't replace the real stuff. Okay, switching gears slightly, but still in R&D hardware. We have to talk about GPUs, right?
Oh, absolutely fundamental. Can't overstate it.
Yeah.
The progress we've seen in AI is, in large part, thanks to GPUs, graphics processing units.
Because they can do lots of calculations at once.
Exactly. Parallel processing. Perfect for the kind of math needed to train these huge models. Cuts down training time dramatically. GPU advancements are like a core enabler.
And the report mentions big improvements not just in speed, but also energy efficiency.
Yes. Raw performance keeps climbing, which is great, but the energy efficiency gains are maybe even more important long term.
How much better are we talking?
Well, take the NVIDIA B100 chip from 2024. Compared to the P100 from 2016, it's reportedly something like 33.8 times more energy efficient.
33 times. That's huge. Makes AI potentially more sustainable then.
That's the hope. More powerful and potentially less energy hungry. It's a critical development.
Okay. And lastly, for R&D, open source AI software. That's becoming more common.
Definitely. You can see it on platforms like GitHub. The number of stars or favorites on open source AI projects keeps rising.
Why is that trend important?
Well, again, it democratizes AI development. More people can access, study, build upon these tools. It speeds up innovation, encourages collaboration.
Makes sense.
The U.S., Europe, China are the big contributors here. So it points towards a more collaborative, faster-moving AI world overall.
Okay, so R&D is humming along, getting more efficient, more collaborative. Let's move to performance. How good is AI actually getting at doing things?
Right, technical performance. This is where you really see the speed of progress. In 2023, researchers came up with some really tough new benchmarks, things like MMMU, GPQA, the SW bench, designed to push AI hard.
And how did AI do on them in 2024?
The improvements were pretty dramatic. On MMMU, performance jumped nearly 19 percentage points in just 1 year.
Wow.
GPQA saw a leap of almost 49 percentage points.
Yeah.
And SW bench, which tests AI on real-world coding problems, it went from about a 4% success rate in 2023 to nearly 72% in 2024.
72%. That's incredible progress on coding tasks.
It really highlights how quickly AI is getting better at tackling complex stuff.
But as AI gets better, we need even harder tests, right? The goalposts keep moving.
Exactly. As soon as models start acing existing benchmarks, like MMLU or Human Evil, researchers are already cooking up harder ones.
Like what?
We're seeing names like Humanity's Last Exam, Frontier Math, Big Code Bench pop up. These are designed so even the best current AIs struggle. It keeps pushing the field forward.
Always striving for the next level.
Yeah.
Now, even with all this, the report says complex reasoning is still a challenge.
Yeah, that's still a frontier.
Yeah.
Even with techniques like chain of thought, where the AI tries to show its work, things requiring really strict, provable logic, especially complex math or intricate planning, remain tricky for LLMs.
So they're great pattern matchers, but true logical deduction is still developing.
That seems to be the case. Getting from correlation to robust causation and complex reasoning is the ongoing challenge.
Okay. Now, 2024 had some major model releases. Any key ones we should know?
Definitely. OpenAI's GPT-4o is a big one. Multimodal handles text, images, audio, and that audio response time is incredibly fast, almost human-like.
Yeah, I saw demos of that. Pretty impressive.
Then there's Alibaba's Qwen 2 series, very competitive LLMs. Yeah. Also, the global MMLU benchmark is important, tries to be more multilingual, less US Euro-centric.
Good.
And OpenAI's newest, O3, it's in beta, seems to be pushing performance even higher on tough benchmarks. So the cutting edge keeps moving fast.
It sounds super competitive. What about that whole open weight versus closed weight debate, Llama versus GPT kind of thing?
Yeah, that discussion is ongoing. Big arguments on both sides. Open weight folks, like Meta with Llama, argue it boosts innovation, transparency, lets more people contribute.
Prevents monopolies, maybe?
That's part of the argument, yeah. But the closed weight side raises concerns about misuse, misinformation, harmful applications. They argue keeping it proprietary allows for more control, safety.
So access and speed versus control and safety. A classic tech dilemma.
Pretty much. It's a fundamental tension shaping how AI evolves.
Now here's something interesting. The report says smaller models are getting better too, after all that talk about massive models.
Yeah, it's a fascinating countertrend. It shows progress isn't just about brute force scale. We're seeing smarter, more efficient architectures emerge.
Like what?
Take Microsoft's Phi 3 Mini. Only 3.8 billion parameters, tiny compared to the giants. But it hit a performance level on MMLU that used to require models hundreds of times larger, like PolM.
Wow. So you can get good performance without needing a supercomputer and a trillion tokens.
Increasingly, yes. It suggests we're getting better at the design of these models, not just feeding them more data, more efficient intelligence.
That's really encouraging, and it seems the very top models are getting closer in performance, not just one or two companies dominating.
Exactly. The frontier is getting crowded. Multiple providers, OpenAI, Google, Anthropic, others have models performing at extremely high levels now.
How do we know that?
Things like the LMSYS Chatbot Arena Leaderboard, which uses crowdsourced comparisons, show this convergence pretty clearly. It means more choice, more competition at the high end.
A more level playing field. Now, evaluating all these models must be hard. The report mentions automated benchmark creation, AI testing AI.
Yeah, it's a neat idea. Creating good human-designed benchmarks takes a lot of time and effort. And AI is improving so fast, the benchmarks quickly become outdated.
Right.
So tools like Bench Builder are using LLMs themselves to generate new test questions from huge data sets. It helps automate the process, keep the tests relevant. Arena Hard Auto came out of this.
Clever. Using AI to keep up with AI. Now, RAG Retrieval Augmented Generation, we hear that acronym a lot. What is it, simply?
RAG basically lets an LLM pull in information from outside its training data, like searching the web or a specific database before it answers your question.
Ah, so it can access up-to-date info, make its answers more factual.
Exactly. More accurate, more current, more relevant. It's key for real-world use.
Yeah.
And yeah, there's now a big focus on evaluating RAG systems, with benchmarks like Ragnarok, Crag, Finance Bench popping up.
Makes sense. You need to know if the retrieval part is actually working well. What about other specific skills, like function calling or text embeddings?
Seeing progress there, too. Function calling, letting AI interact with other software or APIs, is getting better, tracked by things like the Berkeley Function Calling Leaderboard.
So AI can do more things.
Right. And text embeddings, ways of representing text meaning for AI, are improving, too. Voyage AI has a top model on the MTEB benchmark for that. It all means AI is getting better integrated into the digital world.
Okay, piece by piece, the capabilities are improving. Now, this sounds like a big one. AI hitting human level on a visual reasoning test, VCR.
Yes, visual common sense reasoning. That's been a tough nut to crack. AI historically struggled compared to people. But in 2024, a model finally hit 85.0 on VCR, matching the human baseline.
That feels significant, understanding why things are happening in images, not just what's in them.
Exactly. It's a major step in AI's ability to perceive and reason about the visual world more like we do.
Wow, okay. And generating images and video. That's moving incredibly fast too, isn't it?
Unbelievably fast. Text-to-image models keep getting more realistic, more complex. Google's Gemini 2.0 Flash Thinking XB1219 is leading one leaderboard now.
Video.
Video generation is exploding too. Meta's Movie Gen now has editing features. Google's VO and VO2 are showing really impressive results, outperforming older models in head-to-head tests. AI creating complex visual content is becoming commonplace.
Getting scary good, some might say. What about coding? You mentioned the SWE bench jump.
Yeah, AI for coding is a hot area. Specific benchmarks like Big Code Bench track progress. Models from Google, Gemini XP1206 and OpenAI 01 are doing really well. AI is definitely becoming a powerful coding assistant.
Not just writing emails, but writing software. Okay, How about really specialized stuff, like high-level math?
Even there, we're seeing breakthroughs. Alpha Geometry 2 solved an International Mathematical Olympiad geometry problem in 24 seconds during the competition.
Whoa! Okay, that's serious capability, combining neural nets and symbolic logic, right?
Yep. Shows AI tackling really abstract, complex reasoning.
Now, IRC-AGI, that sounds like a benchmark aimed at more general intelligence.
It is. ARC-AGI tests if an AI can learn general problem-solving skills and apply them to totally new, abstract tasks it's never seen, not just pattern matching from training data.
How's progress there?
It was slow for a long time, but this year saw a big jump. OpenAI's O3 model got a much higher score than previous attempts. It's just maybe, a step towards more flexible, adaptable AI thinking.
A step towards AGI, perhaps. Very interesting. Lastly, technical performance. AI agents and robotics.
Yeah, AI agents, autonomous systems working towards goals are huge research areas. Benchmarking them is hard because they need to do so many things. But benchmarks like Visual Agent Bench are emerging.
And robots.
In robotics, DeepMind's Aloha showed impressive dexterity, like complex manipulation skills. And we're seeing foundation models for robotics pop up, NVIDIA's GR0T, Covariant's RFM1, aiming for robots that understand language, navigate better.
So more general-purpose robots.
That's the idea. And in the real world, Waymo's driverless miles are way up. Robotaxis are expanding fast, especially in China. Autonomous systems are definitely moving beyond the lab.
It really does feel like sci-fi inching closer. Okay, so incredible technical leaps, which makes the next topic even more crucial. Responsible AI.
Absolutely, with great power. You know the rest. And this area is complex and evolving. One stark point for you. Reported AI incidents hit a record high in 2024.
Oof, that's sobering. More powerful AI, more potential for things to go wrong.
It certainly highlights the real-world risks as AI gets deployed more widely.
Is evaluation catching up, or developers testing for responsibility, safety, bias?
It's happening, but it's not yet standard practice like performance testing. We are seeing new benchmarks emerge, though. Helm safety, airband, Google's AFTTS for factuality. These are promising tools to measure safety, truthfulness, etc.
So we're developing the tools, at least. That's good. What about transparency? Do we know more about how these big models work?
There's been some improvement. According to the Foundation Model Transparency Index, the average score went up a bit between late 23 and mid-24. But there's still a long way to go, especially on things like detailing the training data, handling copyright. Significant opacity remains. Fully understanding these systems is still really hard.
Got it. Some progress, but far from full transparency. And the report mentions implicit bias remaining an issue, even in models trying not to be biased.
Yes, that's a persistent, tricky problem. Even if you try to scrub obvious biases, subtle ones related to race, gender, professions can linger. Models might still link certain groups to negative ideas or reinforce stereotypes.
So just aiming for neutrality isn't enough?
It seems not. We need deeper methods to find and fix these biases baked into the data and the model's learning process. It's complex.
Definitely sounds like it. Now, elections, AI and misinformation. Big concern. What did the report find?
Well, it confirms AI was used widely in 2024 for election misinformation globally. Deepfake endorsements, AI-generated images in influence campaigns, amplifying dodgy content.
But did it work? Did it change votes?
That's the million-dollar question. The report notes the measurable impact on outcomes is still unclear. The potential for misuse is definitely there, but quantifying its real-world effect is hard.
Okay. Potential confirmed, impact TBD. Can you quickly remind us of the key dimensions of responsible AI the report covers?
Sure. It includes things like privacy and data governance, protecting data, fairness, avoiding bias, discrimination, transparency and explainability, understanding decisions, and security and safety, preventing misuse, ensuring reliability. Core principles, really.
All vital, and it's harder to standardize tests for these things compared to, say, math problem.
Much harder. Responsible can be subjective, context-dependent, culturally specific. Fairness isn't always a simple yes-no. But like we said, benchmarks for specific aspects like factuality are helping make it more concrete.
Right, it's complex. How are companies doing at actually implementing responsible AI practices?
Awareness is high. Implementation is patchier. Many organizations know the risks, talk about RAI, but actually embedding mature processes across the board still seems to be early days for many. A gap between awareness and operational reality.
Knowing versus doing. Okay. Encouragingly, though, academia is focusing more on AI safety and security.
Yes, definitely. More research papers, more conference submissions on these topics. The academic community is clearly taking the risks seriously and working on solutions, which is crucial.
Good to hear. What about privacy and data governance specifically? Any key challenges?
One is just knowing if the data used for training was licensed correctly. There are inconsistencies in how data sets get labeled. Plus, more websites are actively blocking data scraping for AI training. So getting ethically sourced, legally usable data is getting trickier.
The data supply chain is getting complicated. And efforts to measure and reduce bias are ongoing.
Very much so. Researchers are developing better ways to measure implicit bias and new training techniques to mitigate it. One mentioned is LAT-targeted latent adversarial training seems promising for making models more robust against harmful outputs and backdoors more efficiently, too.
Trying to train the bad stuff out. What about AI agents? Do they pose unique RAI challenges?
They do. Because they act autonomously in the world, their decisions have direct consequences. Ensuring they behave responsibly when they can learn and adapt on the fly requires next-level thinking about transparency, control, reliability. It's a big focus area.
More autonomy, more responsibility needed. And just to circle back on election misinformation-specific tactics.
Things like fake video endorsements from celebrities or politicians, deepfakes. Using AI to hyper-personalize misleading campaign messages. Creating fake images of events or protests to sway opinion. Amplifying hate speech automatically. A whole toolkit, unfortunately.
A sobering reminder of the dual-use nature of this tech. Okay, let's shift now to the economy. How is AI impacting jobs, funding, productivity, key developments in 2024?
Big money continue to flow. Lots of major funding rounds for AI startups, showing investor confidence is still high, and that Microsoft move hiring most of Inflection AI staff and licensing their tech for a huge sum that really highlighted the intense competition for talent and IP.
Yeah, that sent ripples through the industry. What do AI jobs? Where's the demand?
The report tracks AI job postings country by country. Gives you a sense of where the skills are most needed, where the development hubs are. Useful data for understanding the geography of AI work.
And funding for generative AI specifically. Still hot.
Very hot. Generative AI companies attracted a huge chunk of investment in 2024. Shows where the market sees massive potential right now, creating text, images, code, etc. That's likely to remain a major economic driver.
Where are these funded companies located? Still mostly the U.S.
Predominantly, yes.
Yeah.
The U.S. consistently leads by a wide margin in newly funded AI companies over the last decade, well ahead of Europe and China. It's still the main hub for AI startups and venture capital.
Okay, U.S. leads the startup scene. What sectors are getting the AI investment? Is it just tech?
Oh no, it's really broad. Investment goes into core AI infrastructure, sure, but also applications across healthcare, finance, entertainment, business operations, pretty much everywhere. Shows how pervasive AI is expected to become.
AI weaving into everything. Are companies actually seeing benefits? Lower costs, higher revenue?
Yes, according to the report. Yeah. Companies using analytical AI are increasingly reporting cost savings and revenue gains across different departments, marketing, operations, HR. So it seems AI is delivering tangible business value already.
That's the proof in the pudding, right? Is adoption widespread now, globally?
It's getting there. A significant chunk of organizations globally report using AI now. And adoption is picking up speed in developing markets, too, not just the usual suspects. Generative AI is being used for all sorts of tasks within companies. AI is fast becoming a standard business tool.
Moving mainstream. Now, the big productivity question. Does AI actually make workers more productive? Any evidence?
Yeah, the report cites studies showing real productivity boosts. In customer support, consulting, software engineering, AI tools led to significant gains.
Interesting.
And often it helped lower-skilled workers improve the most, kind of narrowing the gap with top performers. So potential for increased efficiency and maybe leveling the playing field a bit.
That's a positive angle, but it's not automatic, right? You have to implement it well.
Exactly. The studies suggest you get the biggest gains when AI is deeply integrated into workflows, not just bolted on. It requires thoughtful implementation, changing how work is done.
Makes sense. Can't just buy an AI tool and expect magic. Lastly, on economy, industrial robots. Still growing.
Yep, installation of industrial robots worldwide keeps climbing. Many are powered by AI now, making them smarter, more flexible. It's a big part of AI's impact on manufacturing, logistics, automating physical tasks.
So AI is impacting both knowledge work and physical work. Okay, let's switch to another huge area, science and medicine. This feels like a really hopeful application space.
Absolutely. Transformative potential here. And 2024 saw incredible milestones. Like we mentioned, 2 Nobel Prizes were linked to AI-driven research. Chemistry for AlphaFold's protein folding work, physics for foundational neural network contributions.
Nobel Prizes, that's massive validation.
Huge. Plus, we saw a surge in large-scale foundation models built specifically for medical tasks. It really signals AI becoming central to scientific discovery in healthcare.
Okay, let's talk AlphaFold again. Predicting protein shapes was huge. What's new with AlphaFold 3?
It's even more capable. Now it can model how small molecules, like potential drugs, interact with proteins. That's massive for drug discovery, understanding how a drug might work at the molecular level.
Game changer for pharma R&D.
Potentially, yes. And crucially, it's still open source, available to researchers everywhere. That could really accelerate biological research and drug development globally.
Democratizing discovery, that's powerful. And AI is helping with protein sequences too, not just shapes.
Definitely. AI models are getting much better at analyzing protein sequences, predicting their properties. This speeds up structural biology, molecular engineering. Models like ESM3 and ESMC are pushing the boundaries here. More and more protein research papers are AI-driven. AI is becoming indispensable for molecular biology.
Feels like a golden age for computational biology, but data sets, are the medical data sets good enough? Diverse enough?
That's a major caveat. A lot of the training data comes from limited geographic areas, mostly the U.S., raises big questions about how well these AI models will work for diverse global populations.
Bias creeping in through the data.
Potentially, yes. Or just models that aren't optimized for different groups.
Uh-huh.
There's also a lack of public 3D medical imaging data, which is richer than 2D. And overall, medical datasets are tiny compared to the text-image datasets used for general AI. Data scarcity and diversity are real challenges here.
So great tools, but need better, broader data. Are we seeing foundation models specifically for medical images, though?
Yes, that's happening. Models trained on vast amounts of medical scans, or on pathology slides, whole slide imaging. These could significantly help doctors spot diseases earlier, more accurately. Big potential for diagnostics.
And AI helping doctors with text, notes, decisions.
Also growing fast. NLP in healthcare is often focused on decision support. Studies show models like GPT-4 can assist with patient care tasks, potentially improving clinical management.
And those AI scribes that listen in?
Ambient AI scribes, yeah. They aim to automate clinical documentation, freeing up doctors from paperwork. Could mean more face-to-face time with patients.
That would be welcome. What about understanding social factors affecting health, SDOH?
Social determinants of health. AI is being used to extract that info, housing, food access, etc., from patient records and notes. Gives doctors a fuller picture. Models trained specifically for this work well and can help make care more equitable by highlighting non-medical needs.
Seeing the whole patient, not just the disease. Great. Any other cool science AI models?
Yeah, beyond medicine too. Aurora is a foundation model for weather and climate forecasting. Fizzbird analyzes physics texts. Plus, the number of FDA-approved AI medical devices is soaring. And synthetic data is looking promising in medicine too, for training and privacy. AI's impact across science is just huge and growing.
Really feels like a scientific revolution brewing. Okay, so with all this power, how are we governing it? Let's talk policy and governance.
Critical area, moving fast. Big global moves in 2024. The EU Parliament passed the AI Act. That's a landmark comprehensive regulation.
The first major bloc to do that, right?
Yep. Then the UN General Assembly passed a resolution on safe, secure, and trustworthy AI. And the UK and South Korea co-hosted a major AI safety summit. Lots of international focus on setting rules.
Global consensus building on the need for rules anyway. What about in the U.S., more state or federal action?
Definitely more action at the state level right now. The number of state AI laws passed more than doubled last year. Local policymakers seem keen on regulation too.
But federal action is slower.
Slower, yeah. We did see a U.S. judge block a California AI law about deepfakes, citing free speech concerns, so there are legal challenges too. Elsewhere, Saudi Arabia launched a big AI initiative, Project Transcendence. Latvia, Russia, others are regulating specific areas. It's a patchwork.
Different approaches everywhere. You mentioned lots of bills proposed in the U.S. Congress, but few passed.
That's right. Lots of proposed legislation. Reflects growing awareness. But actually getting laws passed is tough. Complex tech, lots of debate, hard to find consensus. California did pass the Social Media Transparency Act, part of a broader tech accountability push.
Slow process. What about government spending on AI? Where's the public money going?
Hard to compare directly between countries due to data issues, but a key finding. In the U.S., public AI funding is heavily skewed towards defense.
Really?
Yeah. Whereas in Europe, more public AI money goes towards public services, education, health. A pretty stark difference in priorities and strategic focus between those regions.
Fascinating difference. Okay, let's shift to education. Preparing people for this AI future. How's that going?
It's seen as crucial, obviously. Need an AI-literate population and workforce, developing both understanding and building skills.
Is basic computer science education spreading in schools? K-12.
Yes, good progress there. About 2/3 of countries now offer or plan to offer K-12 computer science. Big jumps in Africa and Latin America, which is great.
But are there gaps? Equity issues?
Still significant gaps, unfortunately. Access often depends on socioeconomic status, location, race, ethnicity, especially in the U.S. Girls remain underrepresented in CS classes and AP exams.
And is AI itself being taught?
Not explicitly in most core curricula globally. It's often just a small part of broader CS or ICT classes. So foundational CS is spreading, but specific AI education in schools is lagging.
Room for improvement there. What about university level? More computing grads?
Yes, computing bachelor's degrees are way up in the U.S. over the last decade.
Yeah.
But again, representation issues persist across racial ethnic groups in bachelor's, master's, and PhD programs. Similar trends in other OECD countries for ICT grads.
And are these grads getting enough AI training? Are teachers prepared?
That's the question. Curricula vary. And many K-12 CS teachers in the U.S. feel they aren't equipped to teach AI well, even though they know it's important. So need more grads, more diversity, and better AI-specific training within those programs and for teachers.
Lots of work needed on the education front. Okay, finally, public opinion. What do people actually think about all this AI stuff?
It's mixed, as you might expect. Interestingly, despite self-driving tech advances, Americans are still pretty wary of autonomous cars. Fear decreased slightly from 2023, but distrust remains high.
But local policymakers support regulation.
Broadly, yes. Globally, though, there's a trend of increasing optimism about AI product services, especially in countries that were more skeptical before, like the UK, Germany, US, Canada, France.
Oh, really? So attitudes are shifting, becoming more positive.
In some key Western countries, yes, it seems so. But views still vary a lot globally. Asia and Latin America tend to be more optimistic overall. Europe and the Anglosphere remain generally more cautious or skeptical.
And what about specific concerns? Privacy, bias.
Those concerns are slightly rising globally. Data privacy and potential discrimination are top worries mentioned. So, while optimism might be up in some places, these ethical concerns are definitely still present, maybe even growing a bit. Public trust is key and needs ongoing attention.
A complex picture. Okay, bringing this all together. After diving into this massive report, what are the main takeaways, the big themes?
I'd say, 1, incredibly rapid capability advancement across the board. 2, responsible AI frameworks are evolving, but unevenly and lagging behind capability. 3, the economic impact is real, growing, and widespread. 4, global attention on policy and education is high, but approaches and progress vary hugely.
It's a technology transforming everything, everywhere, but in different ways and at different speeds with lots of open questions.
Exactly. It's dynamic. This report is a snapshot of a field changing almost daily. Research, deployment, societal integration, it's all in flux.
So maybe a final thought for our listeners as they digest all this. Given AI's incredible power and potential, but also the risks and challenges we've discussed, how do we steer this thing? How do we make sure we get the benefits, manage the downsides, and ensure it genuinely serves humanity well? That feels like the question we'll be grappling with for a long time.
Absolutely. It's a central challenge. And for anyone wanting more detail, the full HAI AI Index Report 2025 is definitely worth exploring. There's so much more depth in there. Keep learning, keep questioning.